Hello team, today's challenge is Magic Square Solver, where we're given a 3x3 grid and we need to figure out what this 0 is. Specifically with a magic square, each row, column, and diagonal sum to the exact same amount, right? So in this case, I think it's 15, 6 plus 7 plus 2 is 15, 9 plus 5 plus 1 is 15, so on, etc., all the way through, right? So we're going to do that math. We're going to find out that 0 is 5, and that's what we're going to return. In the case of the second one, it's going to be 4. For the third one, it's going to be impossible. So if we cannot do it for whatever reason, we're going to return impossible. And for this feels very much like a challenge that we've done in the past, which is tic-tac-toe. Okay, it's a challenge that we actually revisited as well, which is why if you look here, all of my code is commented. But the important part is this, right? We have a grid of fixed positions, or an array of fixed positions that we can loop over and test very, very quickly. And that's where we're going to start today. So back over here, we're going to jump into the code and do exactly that. Now, this looks a little bit different because these positions are relative, right? They're kind of in their spot. Last time we did a flatten, which meant that there was only a row, right? There were only columns there and a single row. This time we have both, so a little bit of a different information, but we have the row, right? It's 0 with the column being 0, 1, and 2. Then row 1, 0, 1, and 2, row 2, all the way down, all the way through, getting it done. Okay. From there, we also need a tool to sum up the values of an array, right? This is something that we've seen before. So we'll go sum array, tossing in array just like this, spelling it right. My fingers don't want to work this morning. That's okay. Return array dot reduce. Okay. Reduce takes two arguments, the accumulator and the current, and we add them together, right? So array plus current, and our default starting value, which in this case you could leave it off, but I like to start with 0 just to keep things consistent. And I did something wrong. I used array instead of accumulator. There we are. Okay. So this tool is going to let us sum up each of those rows because we're going to do a lot of that, right? So one way or another, we're going to be using this. And then these lines are going to allow us to test each direction, right? And that's what we're going for here. Now, before all that, we need a few pieces of information inside of our main function here, okay? We need to know what row has a 0. And on top of that, we need to know which column in that row has a 0. So let row, just like this, equal -1, seems like a good place to start. And then the same with column, just like this. We also need to know what the magic or what the missing number is, right? Missing number, which currently starts at 0, but we're going to change it. And then the last thing is the magic constant, right? And the magic constant is that sum number, right? That's going to allow us to test it. So we're going to run up a total that is going to be our magic constant. And then using this these test lines, we're going to test against magic constant. And if every one of those lines sums up to magic constant, then we found it. We have a working magic grid, right? A magic square, sorry. But we need to figure these out, so let's do that. So for let I equal 0, right? Pretty standard loop. I is less than grid.length and I plus plus, okay? So we're operating on that. In this case, it gets really simple. We only need to operate on the rows. So we aren't going to dig into the columns on this one because we're just trying to fill in these missing values, right? That's the whole goal. So with that, we can do stuff. Now, because I'm going to use that row several times, I'm going to pull it out. So let current equal grid I, okay? I'm calling it current because I've used row up here, right? So naming things is hard. Current feels like a pretty good variable name, right? Now, inside of here, we have that condition. We go current.includes like this. If it includes 0, we want to do one thing. What do we want to do? We want to fill in row and column, right? So row equals I and column equals current.index of 0, which is guaranteed to have a value because we just figured that out, right? We know that it includes it, so it's going to include something. We don't need any other tests for that. We just get it done, okay? So we filled in those two values down here. If it doesn't include a 0, then we figure out what our magic constant is, okay? And for that, we go magic constant equals, sum array like this of current. Excellent. So now we have those pieces of information. We figured out if it has a 0, we know which one it is. If it doesn't have a 0, we tally it up and we do the sum, okay? And there is a chance with the way that magic squares work, if our 0 is in the first row, then we're going to do this twice. Realistically, we're always guaranteed to calculate magic constant twice, right? At least with the grid that we have. So something to be aware of. If you wanted to, you could write a couple extra tests there to check if magic constant was undefined, or if it wasn't undefined, and skip it, right? If you wanted to try and do that. Really, because of how small it is, I don't think it's a big deal. So moving on. We have that, and down here we can get our missing number, right? Our missing number is the other piece of the pie. So missing number equals magic constant, because we got that from before, minus something. Minus what? Well, we know where the 0 is, so we're going to grab that row, sum it up, and subtract it from magic constant. So sum array for grid row. Okay, we don't need the column yet. We just need the row to figure stuff out. Okay, at which point we are in really, really good shape. Okay, now down here, we we want to create a new grid. That's the words that I'm looking for. We're about to reinsert our missing number into grid so that we can run all of these tests on these lines and see if it works. But if I just change grid directly, then I'm creating a side effect because it's passed in by reference, and anything passed in by reference means that any other function that relies on grid will have different information, right? I don't want to do that. So right here, I'm going to go const new grid, send it equal to structured, clone structured, just like this, structured clone, can't type this morning, and passing in grid. This will create a deep copy of this for us so that we can do stuff. So new grid for row and for column, okay? Send that equal to missing number. Brilliant, okay? We're also going to return missing number. So let's go and do that right now. If everything works, we're going to return missing number. But before that, now we have this new grid and we're going to test every line, right? That's the whole goal. So now that we have all this set up, we can go for let line of test lines, just like this. And what are we doing? Well, the test lines, the line itself is positions, and we need to get the values. So let's do that first. That's going to be our nums, our numbers. We're going to set that equal to line.map. We're going to map that to row and column and pull out those values. So new grid for row and column, right? That gets us our values, which means that now we can sum it. So const sum equals sum array, just like this for those numbers, right? And then we can test it. So finally, we go sum not equal to magic constant, right? If it's not equal, then we return impossible. Otherwise, we return the magic number. And in theory, it works. It absolutely does, okay? So a lot of little steps, but I've tried to reduce the looping as much as possible. So as much as I can, I go through this loop once and get as much information as I can, right? I need to do a little bit more in here to get the missing number, but with one loop, I can get the position of the 0 and the magic constant. Great, we do that. And then down here, I create a clone of the grid because I don't want to change the grid, right? That's bad news. Reinserting that magic number so that now I can do my second loop. And my second loop goes through and tests each against each line. It tests to see if, it gets those numbers out, it gets the values out, then it sums it up, and it tests to see if that sum is equal to the magic constant, because that's how magic squares work, right? Everything has to sum up to that magic constant. If it doesn't, then we need to return impossible. Otherwise, we return magic number, okay? The last little bit on this is just a sideline for this these test lines. Today, I've tried to make it really easy just by inserting this, right? This grid, which is easy enough, right? But magic squares can be more than just 3x3 grids. And so one thing that I would probably do is I would probably grab some code here, right? Comment this out for a second and paste this in. Now this one, generate test lines. And all we need is a size, because there's an assumption that a magic square is a square, right? Let's just keep going on under that assumption. So again, trying to keep the looping as small as possible, but we're going to generate our lines, okay? We have a diagonal, we have two diagonals here and our rows, right? And so for every direction, we tally it up. We do some work on diagonals, and then we push into our row and column, pushing those rows and columns into lines, pushing those diagonals into lines, returning the lines, right? This is a little bit of work, but it allows us to change the dynamics of the magic square, right? The magic square. So with this, I should be able to have any size magic square, which means that down here, instead of something like this line, right, I can save this one. And what did I call it? I call it generate test lines, right? So bringing that back down to right here and tossing in new grid dot length, okay? At which point it all still works, right? And it works great. But now whatever the size of the grid is, on the assumption that it is a square, I should be able to run this without problem. And I no longer have this hard-coded list of values up here. Instead, I've generated brand new every single time, okay? Bit of a stretch goal there, so didn't explain that one too much, but hopefully the rest of it makes sense, right? We need to dig out the data. We do that in our first loop, and then we test it. We test it all in our second loop. And if it works, great, we return the number. Otherwise, return impossible. Done, right? Not every solution, just hopefully one good solution. If you liked it, if you hated it, if you went a different way, let me know all that stuff in the comments. Otherwise, today this has been Magic Square Solver, and I will see you in the next one.